Question. The largest number which divides 70 and 125, leaving reminders 5 and 8 respectively is option A 13, option B 65, option C 875, option D 1750. Answer. Let us assume that the largest number we need is B. That means when 70 is divided by B, remainder is 5. That implies D divides 70 minus 5, that is equal to 65, leaving no remainder. Consider this as the first statement. And also we are given that when 125 is divided by B, remainder is 8. Which means D divides 125 minus 8, that is 117, leaving no remainder. Consider this as statement 2. From statements 1 and 2, D must be common divisor of 65 and 117. So we need the largest of such common divisor. By definition, D is HCF of 65 and 117. Now let us find the factors of 65 and 117 using prime factorization. First, 65. Let us start with the prime number 2. 65 is an odd number, so it is not divisible by 2. The sum of the digits 6 plus 5 is 11, which is not divisible by 3. Therefore, 65 is not divisible by 3. Let us move to the next prime number 5. 65 ends with 5, so 65 is divisible by 5. 5 times 13 is 65. And 13 is a prime number, so the prime factorization for 65 is done. 65 is equal to 5 times 13. Now let us start the prime factorization for 117. Starting with prime number 2, 117 is an odd number, therefore it is not divisible by 2. Let us move to the next prime number 3. The sum of the digits 1, 1, 7 is 9, which is divisible by 3. Therefore, 117 is divisible by 3. Let us divide it by 3. 3 times 39 is 117. Now 39. Let us continue the prime factorization of 39. Let us check the divisibility by 3. 3 plus 9 is 12, which is divisible by 3. Therefore, 39 is divisible by 3. 3 times 1, 3 is 39. And let us continue with the prime factorization for 13. 13 is a prime number. Therefore, 117 is 3 times 13. And from both the prime factors for 65 and 117, we can see that 13 is a highest common factor. Therefore, D is equal to HCF of 65 and 117 is equal to 13. Therefore, the answer is the largest number that divides 70 and 125, leaving remainders 5 and 8 respectively is option A 13.